In this video, we're going to talk about how to determine the angle between two vectors using the dot product 3D Cartesian setup. We're going to be using this dot product formula here. It's pretty straightforward. You just find the dot product of two position vectors and then divide it by the magnitudes of both position vectors. So the first thing we need to do is find the position vector for each of our desired points here. So since it's the origin point, we're trying to find the angle between these two vectors. We want to find a vector of both A going to B and then A going to C. So first thing I like to do is just define all my points. So point A is, it's only going on the x-axis here, so it's going to be 3. And then the rest is going to be zeros. And if we take a look at point B, it's not going down anywhere on the x-axis, but it is going in the negative direction in the y-axis and in the positive direction in the z-axis. So it's going to be 0 and a negative 0.75 here for the y-axis. And a positive 1 in the z-axis. Point C, once again, doesn't go anywhere on the x-axis, but it's going in a positive y direction and a positive z direction, so it's going to be 0, positive 1, and then positive 1.5. So after that we have all our points defined, we can actually find our position vectors. So starting with the position vector of A to B, B is going to be our head, and then A is going to be our tail. So it's always head minus tail. It's another reason why I like to line these points up like this. So it's kind of, you can kind of visualize the best way to subtract this. So in this case, since B is the head, which would be here, we just need to subtract it by these A values. So 0 minus 3 is a negative 3. So I'll give us negative 3 I direction. And then negative 0.75 minus 0 is just negative 0.75. In the J direction. And then 1 minus 0 is 1. And don't forget to put your units, which in this case is meters. And then since we have this position vector, we know that we're going to have to divide our dot product by the magnitudes of the individual vectors. So we'll just go ahead and find the magnitude of this vector. So as you recall, the magnitude, it's going to be the square root of all our points along the vector squared. So we'll have a negative 3 squared plus negative 0.75 squared plus 1 squared. And that's equal to 3.25 meters, so you maintain those units. Now we have to find this vector from A to C, so we just do the same thing again, head minus tail. So C is here, this could be our head, and we subtract this A point, so I'll be 0 minus 3 again, it's negative 3i, 1 minus 0, it's 1, and then 1.5 minus 0 It's 1.5 in the k direction. We have our units, and then we're going to find our magnitude for this as well. It's -3 squared plus 1 squared plus 1.5 squared. We'll end up with a value of 3.5 meters. Now we have to find the dot product value for our numerator. I like to do this by just lining my two vectors up, like one above the other. It gives me like a better visual aid. So, do this down here. So first I'll just start with our position vector going from A to B. Then I'll write our position vector going to AC. Then I know I could go ahead and perform the dot product. So each segment is lined up perfectly. So coming up here, we can multiply our I values together. So that gives us a +9. We can multiply our J values together. So that gives us a -0.75. And then we can multiply our K values together, which gives us a +1.5. Now we can just add and subtract all these values together, and that gives us a total of 9.75. So what this does when I line it up, I can just multiply these together and then pretty much get the answer below, and then just add them all together, and that gives us our numerator dot product value here. And then now that we have both, now we have the numerator and we have both of our magnitudes here and here, we can go ahead and plug it into this formula and get our final answer. So we have theta is equal to cosine inverse of 9.75 over 3.25 times 3.5. That gives us a final answer of 31 degrees. So for these problems, it's just a matter of just staying organized. I feel like it's always a good idea just to define all your points first, and then get all your position vectors, and then you can just kind of work down the line. Once you know to get that position vector, you're going to need that magnitude as well. Just always reference your formula, because it kind of tells you everything that you need to do. So find a way or an order that you can remember it the best. And then for me, it's always just define the points, get the position vector, and then find the magnitude immediately after that position vector, and then go to the other position vector. And then I align my two position vectors and get my dot product here.